Hello, my amazing Algebra I students. This is Mrs. A, and I love math. And today we're doing lesson 21, which is all about exponents. Here we go.
Okay, so here we are talking about the product rule of exponents. We're talking about addition. When we're adding like terms with exponents will also be covered in this one. And here's some basics here. When we say 3 to the 5th power, we mean 3 times 3 times 3 times 3 times 3. So there's 5 3's multiplied together. And the shortcut for that is 3 to the 5th, which you probably already knew. Also, when we do 3 squared times 3 cubed, that's going to be 3 squared is 3 times 3, and then 3 cubed is 3 times 3 times 3. And all together, don't we have 5 3's multiplied together? So we end up with 3 to the 5th. So let's look at the pattern here. When we multiply like bases together, we add the exponents. Okay, let's try it with this one and see if it works. 3 is really just 3 to the 1st power, isn't it? 3 times 3 to the 4th is a single 3, and then 3 plus 3 times 3 times 3 times 3, 4 times, and then when we multiply them all together, don't we have 5 of them? So we get 3 to the 5th. So our pattern is when we multiply like bases, we add the exponents. Now, anytime we have just a single digit, it is that digit to the 1st power. So that is really a 3 to the 1st power. So 1 plus 4 is 5. So to multiply like bases, we add the exponents. X times X times X, so that's all the same base. So 5 plus 7 plus 2 is 14. And that is the big rule of the day.
So here is the rule. We're going to call this the product rule for exponents, and it is simply that x to a variable exponent m times x to the n exponent is the same thing as x to the m plus n. So that's our rule. So that's when we put variables in it so that it stands for anything. So x to the m times x to the n is x to the m plus n. So when we multiply like bases, we add their exponents, and that is called the product rule for exponents. So let's practice. 5 squared times 5 cubes times 5 squared. Since they all have the same base, our answer will be 5, and then we add together 2 plus 3 plus 2, and that would give us 5 to the 7. And that will be our answer. Okay, so on this one, we've got p to the 5 times p to the 12 is going to be p to the 5 plus 12 is equal to p to the 17. And the last one, I'm going to write without this middle step because the middle step's not really necessary. It's just because I'm teaching you right now to do that. So we have all 4's. So 4 is the base, and now I add together each one of these. So 25 plus another 5 is 30. So 4 to the 30 will be our answer. So here's another example, and notice that I have x's and y's here. So I'm going to take the x and the x, and those two are going to be joined together to get me x to the 2 plus 5 is x to the 7. And then I'm going to join my y's with multiplication, and I will get y to the 2 plus 5, or 2 plus 3, excuse me, or y to the 5th. And so the rule is I must multiply like bases together, but I can skip around just like that. So it doesn't matter that I jump over here and get my 2 x's and put them together, and jump over here and get my 2 y's and put them together. Likewise, on this problem, I've got x's, y's, and m's. So that's not a problem. I will join my 2 x's together, and x squared times x cubed would give me x to the 5th. and then I join my two y's together, and I've got a y to the 3 plus 2, or a y to the 5th. And I've got this poor little lonely m. He doesn't have anybody else to go with. So I just put down m to the 5th. And I do not have to worry about which order I put them in. I do not have to put variables in alphabetical order. Sometimes you will see them in that order, but it's not mandatory. Here is another rule. X to the first power is the same thing as x. Whenever the power is not specified, it is 1. Okay, so x to the nothing specified is x to the 1. So let's use that as we look at these. We've got an x to the nothing specified, so that will be x to the 1 times x to the 3 is going to be x to the 1 plus 3, or 4. And nothing is specified here, so that will be a 1. So we have y to the 1 times y squared. And remember, when we see variables right together, that's an understood multiplication. We don't have to have the dot there. So y to the 3, and that's my answer. This is our last example on part A of this lesson. So we've got a hodgepodge here, m's and p's and x's, but that's it. And they're in all sorts of orders. So let's just grab our m's since they're starting out first. And we've got an m there and there. So three m's to join together. Remember, this one is going to be an m to the 1 right there. So 3 plus 1 plus 2 is m to the 6th. Okay, so now we look for our p's. We have a p here, which will be p to the 1, and then a p over here, and that's it, just two p variables. So 1 plus 5 is 6, so that will be p to the 6th. And lastly, we're going to go up there and grab all of our x's. We have an x to the 1, an x to the 3 that we're going to multiply together to get an x to the 4. And it's fine to leave my answer just like this. But if we look down at the bottom of the page on page 92, we see that it's fine to leave it in any of these forms because order is not important. Multiplication is commutative, so we could leave it in any of those. So now let's move on to part B of lesson 21, and we're going to talk about addition of like terms with exponents. So now we're going to talk about adding like terms. Now, a like terms have the same variable parts with the same exponents. So x, y squared would not be like with xy, because here this one is really xyy and this one is just xy. So it has to have the same variables and the same exponents as well. So here we have 3x squared plus 2x squared, which is 5x squared. We could actually undistribute or factor out the x squared. So we could say, oh, they both have an x squared, so we'll write the 3 plus 2, and then we'll distribute the x squared. So that's a 3x squared plus a 2x squared is a 5x squared, because 3 plus 2 is 5. Now, we don't have to do that every time, but that's the reason why we can add like terms, is because of this distributive property. So now let's look at this example problem down here. We start with an x squared y p5. So now we've got to look for another x squared y p5. Now this one has a y squared x p5, so we can't add that with this one. So we're looking for a p5 and a y and an x squared, so we look here. Well, it does have a p5 and a y and an x squared. Remember, they don't have to be in the same order. So these two are like terms. Now we look at this one, it doesn't match because it doesn't have the yx squared, it has an xy squared. So this one matches this one here because both of these have a single x and then a y squared and a p to the 5. So we can add the two that I've underlined together, and then we can have the two that I've connected with that shape together, but we can't add them all together. So let's add the two that we underlined. And remember, when there's nothing here, it's a 1. So we have a 1 x squared y p5 and a 3 x squared y p5. Remember, the order is not important. So 1 plus 3 is 4 x squared y p to the 5th. So now that we've added those, you can mark them off if you want to. You don't have to. But we only have 2 left, and they match. They are like terms. And so we have a 2xy squared p5 minus a 7xy squared p5. So I'm just doing them in the right order so I know they match, but the order is not important. 2 minus 7 is negative 5, so we now have negative 5 y squared x p to the 5th. And again, the order does not matter in which we write them, but it's very important that they are the same terms raised to the same power. So let's come back with another example. This is your next practice in the book. So again, we need to find out which terms are like terms. So this one has an m cubed. So we need to start with another that has an m cubed. That has an m cubed. That has an m cubed. They all have m cubed. So that's not what we're going to use as our judgment call here. Let's look for an x. That one has an x. This one has an x, but this one has a x squared. Okay, so this one's looking like an oddball to this one. So now we look at the y squared. Y squared, y squared, y squared. And this one we've already decided is an oddball. And then we have a p, and there's a p, and there's a p. So it looks like these first 3 match completely and are like terms with each other. But this one right here is odd man out, and so we're just going to leave him alone and bring him down to the answer. So now that we've decided that all of these have the same terms raised to the same exponents, we're just going to look at this first. This is called the coefficient on the front. We're going to look at the coefficient of each one and do our math with those. So we have a 2 plus a 3 minus a 10 is a negative 5. So down here I'm going to write negative 5. And once I write down the negative 5, then I just copied the first term in exactly the same order it appeared, even though the other two did not have the same order. The order was not important. But this odd guy over there, I just wrote down just like he was because he did not match anybody else. So he stands alone. He's kind of lonely. So let's look at the next example. I've already underlined for you 3 terms that match. X squared y, x squared y, x squared y. Okay, these other 2 terms we're going to have to deal with separately because they're x squared y squared. So we have 2 plus 3, and then this one had nothing there, so I went ahead and put the negative 1 because it was a negative. And so we have 2 plus 3 is 5, minus 1 is 4. So we have 4 x squared y. And then here we have an x squared y squared and a minus 4x squared y squared. So again, this one up here is a 1. So 1x squared y squared minus 4x squared y squared is negative 3x squared y squared. So now we're going to begin your practice problems together. Here's practice A and practice B that we'll do together on one board. So A, we're looking at this. This is from A of the lesson, part A of the lesson, and we have an x term, x, and then we have some y's. So we're going to multiply these 3 x portions together since they have the same base, we're going to remember that this one gets an exponent of 1. So we have x to the 1 plus 4 plus 3 is x to the 8. And now we've got to go back and see what we have for y's. We have y to the 1, and y to the 5 is y to the 6th all together. So that was your practice A. So let's look down here to practice B. So we've got a hodgepodge. We've got x's and y's and m's. So let's deal first with our x's. Get those boards out of the way. So let's deal first with our x's. X cubed and x to the 1, x to the 7. So 3 plus 1 plus 7 is x to the 11. And then we have y squared, y to the 5. Only 2 terms have y. Oh, those are not terms. Those are 2 variable y's. Terms are separated by addition and subtraction. Those are not terms. Those are just variables, 2 y variables multiplied together. So we're going to end up with y to the 7. And then we have m times m. And m times m is m squared. Because again, that's an m to the 1 times an m to the 1. And we have taken care of everybody there. So let's look at the next one. Here is practice C. And now we have different terms. We have 4 different terms joined by addition and subtraction. So we're going to find out which one are like terms. X squared y cubed. X squared y cubed. So those 2 match, and then these 2 are going to match. So we have like terms, so 2 minus 8, negative 6x squared y cubed. And then we've got an xy minus a 5xy is negative 4xy. And now the last practice, here's practice D. So we have an x to the 6y and an x to the 6y. And this one is an xy to the 6th. And then this one here is just a 3xy. So these 2 are like terms, and that's it. These 2 have nothing in common with anything else. So what we're going to have is we can put these 2 together, and they both just have a 1 for a coefficient because there's nothing there. So we will say 1 plus 1 is 2. X to the 6th y plus 3xy minus 5xy to the 6th. So if they don't have like terms, we cannot add them together. We can't combine them. We can tack them on, but we cannot combine them. We're left with all of that. And that is the end of Lesson 21. And this is Mrs. A. And may God bless your day.